Today's March 6th. Well, today's March 7th. We have another winter storm coming in. Did you guys know that?
Yeah,
Tomorrow night through Thursday morning, I think. Another, they say maybe 5 to 10 inches of snow. Ay, ay, ay. There is a much more buffed up version of this lesson that we would call just simplifying radicals in general. And that we either reserve, it depends if we're feeling up to it this year, or more than likely we'll save for Algebra 2. But what we're going to learn today can be applied on many different levels. Today's is just a very fundamental numbers only kind of level. Square roots only, numbers only. Eventually we'll have you simplifying like the cube root of 54, a to the fourth, b to the fifth, and stuff like that. Today, not so much. So that's why in the notes, in the header here, I have us very specifically saying we are simplifying square roots. You'll notice in the assignment when you click on it, if you read such things, that it will say simplifying radicals. And that's just a generalized term for all types of roots. Cube roots, square roots, fourth roots, those are all just called radicals for the record, okay? But we are specifically doing square roots. So the idea becomes as fundamental as this. Back in, I would guess, 4th grade, someone taught you that that is not an acceptable answer, right? And that's just been drilled into you over and over again. You've probably just reached the point where you stopped asking, do I have to reduce my? Yes, of course you have to reduce. It's just become something that we know that we have to do. So as fundamental as that is in your understanding of mathematics, what we learn today becomes equally fundamental, okay? So simplifying a fraction would be to, of course, divide the top and the bottom both by whatever, blah, blah, blah. Today, what we're doing is we are simplifying square roots. So the idea is this. If I gave you the square root of 4, I trust you all know that the answer is 2, right? If I gave you the square root of 100, I trust you all know that the answer is 10. If I gave you the square root of 196, I trust that after at least maybe 4 or 5 seconds, you'd all figure out and agree that the answer is 14. These are all what we call squares. So 4 is a square. 100 is a square. 196 is a square. So when I ask you to square root a square, you just go, oh, that's just in my mind. I know that one. The question for the day, and what we're going to practice now for at least one day, probably 2, is what happens when I give you a number that's not a square. Now, answer number 1 is I type it into my calculator and I get some ghetto-fied 2-point something answer that nobody's interested in. Not in the context of what we're learning today. Not interested in a decimal approximation. Have you guys ever simplified roots radicals before? I feel like in Mr. Manlove's 8th grade, you probably have tapped into this a little bit. I'll show you the way I teach this, and I teach this 2 different ways. For a long time, I was set in what we call a tree. I then have also learned to embrace that not everyone likes the tree. Some people would prefer to work sideways. So here is the square root of 8. The method that I've always preferred is to make a tree. And a tree needs branches. And so off of the square root of 8, I'm going to make 2 branches. And at the ends of the branches, I am not going to put 2 and 4. And listen, I will yell at you a lot. You have figured out kind of what my triggers are. Like when you say up to over 3, you know 100% of the time I'm going to cloud up and rain on you, right? There are things in mathematics that I'm going to hold really, really tight and dear. And one of them is that at the ends of these branches, there are not a 4 and a 2. There are 2 square root signs, first and foremost. I get about 90% of people to do that. And then the other 10%, I kind of feel like you're on your own. Before I do any math at the ends of my branches, I will put 2 blank root signs. Now, I'm ready for that. What 2 numbers multiply to make 8? 2 and 4. And I'm going to choose to put the 4 and the 2 in this order. And you'll see why. First off, before we press on, we all in agreement, right? That if you have a root of 4, and a root of 2, when you multiply those, you just get a root of 8, right? 4 times 2 is 8. And so I haven't done anything different than what we did back in like the way long time ago when your teacher had you make just little factor trees. That's all I'm doing, except the factors that I'm making have root signs on them. And the reason I put it in this order is because what is the square root of 4? It is 2. So my final answer is 2 root 2. And we're going to train ourselves to say them that way. We're not going to say 2 times the square root of 2. It's not wrong. It's just clumsy and right? We just say 2 root 2. 3 simple words, nice and clean. And that is a simplified radical. Easy, right? Let's try another one. Oh, by the way, I said I was going to show you the other way, and let me show you the other way. If you don't like making a tree, you can also work sideways like this. No harm, right? Some people like this better. But notice I'm not going to budge on this. If you don't put those root signs, I'm going to yell at you 100% of the time. And I'm going to make you put them anyway, so you might as well just go, I'm just going to put them, fine. So I got root times root. And again, the process is the same. I'm still going to put in there a 4 and a 2. And I'll ask you the same question. What's the square root of 4? 2. And so you're going to get 2 root 2. It's just a very cosmetic sort of little difference. Do I want to show it as a broken down tree, or do I want to show it sideways? I do not care at all. All right, now let's get into just kind of rapid firing these, and then I'm going to help you and make a thing that we'll come to know as the red list, and that'll help you a lot as you go. Anyways, let's practice a little more. Let's do the square root of 45. And I, in my lecture, will always use the tree for the record. It's what I've always done, and it's what I like the best. At the ends of my branches, what will I put? I will not put 9 and 5. I will put a root sign and a root sign. Now, there are 2 ways to make 45. One of them is, of course, 15 times 3. If I were to put 15 and 3 in here, that would be bad, because what's the square root of 15? Nothing good. 3 point something trashy. And what's the square root of 3? Again, nothing good. And so I have to choose wisely. This will become more difficult as we go. I have to choose to do what Cooper said, and that is make sure you pick 9 times 5. Yes, they make 45, but more importantly, one of them can be square rooted. And what is the square root of 9? So how do we read this out loud? 3 root 5, like an expert. Well done. Okay. And you can, this can go big too. Like you can do the square root of 288. Don't worry, I'm going to slow down here in a second and give you a helper, but I just thought you should know that the numbers can get big. It doesn't necessarily mean like, oh no, I'm in trouble. It just means I better roll up my sleeves and think about some bigger numbers perhaps. Does anyone know any 2 obvious numbers that multiply to make 288? Yes, and so again, before I ever begin, I implore you, you do the same. Put your root signs. Put the skeletal structure, the building space, the workspace. And it's not because I love square root signs, it's because my heart breaks for the thousands and thousands of points that I've had to take off for kids who don't follow those directions and then forget to root the numbers. Ugh. So I'm going to put my root in my root, and I'm going to do exactly what Alyssa said, and I'm going to put 144 times 2, which is beautiful because if I know my times tables, what's the square root of 144? It is 12. And so my answer is 12 root 2. Now I'm going to take a little bit of a detour here, and I'm going to give you something. This is a little gift, and I want you to keep this somewhere in your notes where you can always refer to it. And again, I'll just always call it the red list because I always been teaching for 26 years, and I just tend to make this look the same every time. It seems to help. So I'm going to make a list with you of numbers that are what we call squares. 1 is a square, 4 is the next square. Who's the next square after 4? Nope. Squares are numbers that can be, by definition, whole number square rooted. The next one is, by definition, 9. Next one? 16 is definitely next. Square root of 1, 1. Square root of 4, 2. Square root of 9, 3. Square root of 16, 4. The next one is 25. Because 25, when you square root it, gives you a whole number 5. After 25? 36. And, listen, first off, you're going to have your notes with you, I assume. Secondly, you can always generate these by just, if you haven't figured out the secret yet, we're just squaring numbers, right? So like to get them, it's not like you go, oh, I forgot my list. Well, just make it again. 6 squared after 6 squared is 7 squared. If I square it, then I can square root it. You square to get it, you can square root to undo it. After 49 is 8 squared, which is 9 squared, 10 squared, 11 squared, 12 squared, 13 squared, 14 squared. I'm sorry about that. I put 166. I apologize. 15 squared. And I always run out of room. You'd think after a couple decades that I would know to write smaller, but this always happens. I'm getting closer to the end, but I've still got a few to go. This is where it gets tougher, that we're not really familiar with these. Anyone know 16 squared? It's okay. 256. 17 squared? 289. 18 squared? 19 squared. And of course, 20 squared, we don't need a calculator for that. It's 400. This is the list of numbers for which I will hold you accountable. All right, I trust that you'll memorize these over the coming couple of days. I'm not going to go beyond 20. All right, I never have, never will. In fact, quite often you won't even see those bigger ones. But that I feel like is very reasonable for me to ask that you have those tucked upstairs. Those are called squares. Now, this list becomes important because as we get into some problems now, we need to refer to this list because only the numbers on this list matter to me. And here's a classic example. 32. What's the first times table that you think of when you think of 32? 4 times 8. Someone got paid to get that stuck in your head. Unfortunately, right. And let me just show you why 4 times 8, even though it quote unquote works, it's not a good choice. Because, oh yeah, see how gross. So 4 times 8 equals 32. What's wrong with this? What's the square root of 4? So my answer is 2 root 8. Get off my back. No, because the 8, the root of 8, you'd have to break down on its own again. So now I'd have to go, oh no, off the 8, I got to make 2 more roots. And what makes 8? 4 and 2. I'm always going to put the square rootable one first. I would ask you to do the same. 4 and 2. And what's the square root of 4? 2. Now, at this point, since I've chosen this route to do this problem, I've got to go back now and say, okay, this was a jailbreak. This was a jailbreak. And this is my only leftover. And when I put the jailbreaks together, I get, whew. Isn't there an easier way?
Yeah.
Yes. And this is where the red list, I think, really comes in handy. And it also comes in handy if your brain is capable of memorizing things. What's a better number than 4 on the red list that multiplies to make 32? Yes. 16 is our friend because it's bigger, and the bigger, the better, because that means you're going to likely not have to do multiple steps. And so had I from the beginning chosen 16 times 2, ching, what's the square root of 16? And there's my 4 root 2. And 100 people out of 100 surveyed would rather do the problem that way. One step is always better. The square root of 32 is one of the most commonly missed problems in my years of experience. By $1 for every time someone had put 2 root 8 for the square root of 32, I could probably pay off my mortgage. Got it? Okay, let me give you another one that people tend to miss and see if you can pass the test. This is a tough one. Doesn't matter, algebra 2, college algebra, this one gets missed a lot. The trick here to be good at this is to go through and think about, don't settle for the first thing you find. Because if you settle for the first thing, you're going to settle for something useless because someone before me got paid to get you to memorize that 8 times 6 is 48. Why is 8 times 6 just dog water? Because neither one of them is square rootable. It's terrible. So sometimes we got to think about, okay, I got to branch out and think about different ways to multiply, things I normally wouldn't think of. 4 and 12 would work. However, if I do 4 and 12, then the 12, just like that last problem, is undone, and I'm going to do this in multiple steps. So going back, I realize if I scan the red list and if I go a little bit deeper, and again, these are things that you'll just memorize, there's that 16 again. And who knows this kind of stuff? You will, because you're going to memorize it. 16 times 3 makes 48. And that is awesome, because what's the square root of 16? 4. So 4 root 3 would be the answer. I'm going to give you another one that people miss. This is another one that goes in the category of, ew, if I had $1 for every time someone missed this. Everyone thinks of the ones that I don't want. Everyone thinks of 4 times 20. Nope. It works, but then 20 requires more work. People think of 8 times 10, which is trash. But there's a really good one. And I'll give you a hint. It involves, yet again, the demon number that I have circled at the top of the board. Believe it or not, 16 goes into 80. And this, again, is something that you will memorize if you choose to. Anyone know 16 times what makes 80? Yes. So put your 2 blank square root signs, put a 16 and then a 5. 16 times 5, yep, is 80. And what's the square root of 16? 4 root 5. Got it? How you feeling about this? I'm telling you, if you do one and you don't go far enough, it's going to mark it wrong. Like, it's just like saying if your teacher said, okay, class, let's all reduce a fraction. And you go, okay, here's my reduced fraction. You're going to get that wrong, right? Because you didn't really mess up. You just didn't really finish the problem. Let's go again. Too fast, but it helps that you have good basic skills. The good basics are going to carry you a long ways. So I'm going to begin, as I always do, with 2 square root signs that contain nothing. In the first one, I'm going to put the 25. In the second one, I'm going to put 3. We all know 75 cents is 3/4. So we all then, by definition, know that 25 times 3 is 75. So the answer is what? 5 root 3. Very good. Slow down a little bit, Cooper, okay? Maybe just keep them up here for a little bit because you're powerful. Let's give everyone a chance to think. That's one you don't see every day. 98. No, that's 108. Yes. I will tell you this as a guy who's done this many, many times before. Oftentimes, dividing by 2 will reveal a number that most of us would never have thought of. But we know that 98 can be divided by 2, duh, because it's even, it ends in an 8. And then it just so happens that if you divide it by 2, half of it is, jackpot. And what's the square root of 49? And there's our answer, 7 root 2. Okay. How about this one? I would say, like, you know how early when you're learning something, you form habits, right? And it's very easy to form good habits on the first day instead of spending months trying to undo the bad habits that you've chosen to create. So make yourself the habit of drawing the branches and then putting root. Before you even think I'm going in, just follow directions. And then what did you say? 100 times 3. Perfecto. And what is the square root of 100? 10 root 3. How about the square root of 72? The first one you think of is not the one you want, for the record. Because again, if someone did their job and you took the time to learn your times tables, you thought of 9 times 8 right away. That's a trained response. It's no bueno. Works, but it's not what we want. Yes. So that's where we go deeper into the red list and we say search, search, search. And this is that trick comes in again where I say, you know, just for giggles, let me see, you try 2. Y'all know what 72 divided by 2 is? Jackpot. 6 root 2. You guys feel like you got this? Can you do 40 of these? All right. That'll be it for the notes. We're going to continue on this road here for at least today and probably tomorrow, and then see where the road takes us from there. The assignment should already be posted to Delta Math. I think I had it assigned. It should have posted itself a few minutes ago. Let's see here.